We've heard a lot these days about virtual reality, augmented reality, but have you heard about remote reality, where you virtually control something physical in the real non-virtual world? And what if this physical thing that you're controlling is actually $1 million high-speed electric car in a race series where the drivers could be located anywhere in the world? Well, that's exactly what the startup Avicar is going to do. And today we have with us the founder and CEO of Avicar, Cartier Brown. And he's taking what he's learned in a career in the movies and in music, and he's creating a remote racing series for electric cars. And he's going to tell us all about remote reality. He's going to tell us how the components of everything from the car to the track are being engineered, and all the excitement that is going to be building up around remote racing of electric cars. Cartier Brown, welcome to the Future Car Podcast.
Thank you. Thanks for having me. Appreciate it.
Well, Cartier, let's start at the top. So the vision behind Avicar is to allow people to race these electric cars remotely. They could be located all over the world, unlimited distance between them and the actual racetrack and the cars themselves. All this is achieved through remote reality. So maybe explain to us what remote reality is and how Avicar is taking advantage of it.
Awesome. Absolutely. Would love to. So similar to virtual reality and augmented reality, remote reality is a little different when it comes to the immersive experience. And what it allows you to do is experience other environments in the real world in real time. So you can actually experience something in a completely other area of the earth and experience it in real time. So what's different about virtual reality and augmented reality is that it's digital graphics intensive. Remote reality relies on live stream cameras. So everything is real. You're actually moving physical objects in the real world, and you're essentially in two places at the same time. And there's a whole plethora of things that come with this type of technology that we're really excited about.
So we're all familiar with Formula One, NASCAR, IndyCar, traditional racing. Then there's esports, which is really a video game. But this is, maybe it's a cross between the two. And one of the things you say about it is you say you're doubling down because it feels real, right? Because virtual reality and video games try to make it feel real, but you say it feels real because it is real.
Yeah.
What does this mean in the context of remote reality racing and remote reality technology?
Absolutely. So my background comes from the content video production space. I've been in that space for over a decade. So when it comes down to content and sports programming, more so in particular, one thing we got to realize when we looked at the market was that the younger generation wasn't watching sports as much as the generation that preceded it. And we realized that it came down to a few points on why that was the case. So when they interviewed Gen Z millennials, there came to a few common denominators of why that was the case. One of the reasons was that events that are 90 minutes, 2 hours, maybe sometimes even longer, it's really tough for some of these younger guys who just want to move around and, keep things moving. Another aspect which we found really interesting was the interactivity with the sports. And because there was no interactivity in what they were watching, many of them graduate to social media, where it's much more interactive. than a passive 2 hour programming. So it put us on this rabbit hole of trying to push the content a little further and make it more so instead of just witnessing a sports game or witnessing, sitting on the sideline and experiencing that for yourself, which is really interesting, by the way. There's a lot of, Meta's doing a cool job, and there's a few other companies doing that. But what if you can actually be in the sports game itself? And to be able to control that and the outcome of that and the outcome that affects the real world, that was very, very interesting to us because we realized that has a new dynamic when it came down to sports competition. So remote reality, we came at this essentially at a sports programming content perspective because that interactivity and something that would just connect to a younger demographic. And F1's doing a great job, phenomenal job, and NASCAR, especially with Netflix, how it really spiked that interest amongst early consumers. But just the broad strokes, when you look at the numbers, it's quite interesting. So, for us, we really want to take this a slightly different approach than what Formula One is doing very successful at, and NASCAR and Formula E. But we wanted a motorsports league that you can participate from your living room. You could participate from your couch. And that was something that no motorsport league is doing right now. So that was the journey we went on. That was the, aside from the content aspect, we realized on an engineering and technology aspect, we were opening up a plethora of opportunity. And as we were starting to speak to some of our mechanical engineers and these guys are, really bright people we fortunate to work with. And we just was fascinated by the opportunity that this technology can allow in motorsports. So we just went down this rabbit hole and to change not just sports programming, but technology and a disruptive, immersive experience that was slightly different than virtual reality and augmented reality.
When I mention remote racing to people, they say, oh, well, without a driver sitting in the car and the chance that there might be a wreck or the risk of human life during that's where to some extent where excitement comes in, that's going away. So without that human element of risk and all that, why do you think people are going to want to watch this?
Great question. Well, in fact, remote reality has a ton of risk because it's not completely autonomous vehicles that would have a 100% predictability of exactly driving around the course with precision and zero chance of crash. Remote reality still has that human touch. And that's what's important. It's really the symbiotic relationship between human and machine, where it's not just 100% machines doing all the work. So there is still that element of anxiety as far as who's going to come first, who's going to win, who may crash. But it's also taking into a fact that you could now push the engineering of the vehicles to do things that hasn't been seen before. And that's really what keeps us up at night. The idea that we could actually do things instead of having a car, nicely go around the track or copy F1 or copy NASCAR, we could really push the limits of the courses to go more vertical and do things that haven't been caught on camera yet. And that's really what we think gets to balance out some of that conversation.
Well, tell us a little bit about the car. So there's no driver, so you don't need, no seats, no doors, no airbags. There's restraint systems, whatever it might be. Describe the car. How big? How fast? What's
Awesome.
it look like?
Cool, for sure. So, I think it's one of those I could show you better than I could tell you, and hopefully someone could look up the Avicar Gen 0 model because it's hard to describe. what we think looks really cool. Um,
Well, you have an
but
Italian design firm actually working on it. We know the Italians
yes,
design great cars.
yes, they do. Yes, they do. When you want the best, you got to work with the best. So we reached out to iconic car designers in Italy. Spot a Concept has done remarkable designs. Alfa Romero, Aston Martin. They've done some designs for Ferrari. I mean, you name it. These guys are like the top of their class, and I mean, these are like real James Bond style cars. Um, so we felt they would understand the aesthetic and what we were looking to achieve here, and
How
just
did you explain that to
yeah,
them when you sat down with Spada?
yeah,
What did you say? We
yeah.
want
Good
a.
question.
How do you describe? We want this because this is something that's never been designed before. So what do you
Right.
say? I don't want it to look like a VW Bug, but maybe it could look like a Dino Ferrari. I don't know. How do you do that?
Yeah.
How do you
No,
explain to them the look and feel of a remote reality race car?
I wish you were in the room the first time they were hit with this concept. They stood there for a little bit, and then it was just like they understood the evolution of the two-seater, the cross-country competition, the NASCAR models, the evolution to the one-seater, the single-seater, which was Formula One, and then now this new evolution, which is the zero-seater, where the driver's seat is removed from the vehicle. Um, and they caught on and they loved it, and they were hit with a challenge to create, what kind of embodied a little bit of a progressive modern take on what motorsports is today.
How fast does it go? How big is it?
Mm, mm. Well, we're in research lab mode right now, so this is all R&D. The vehicles can go 200 miles per hour right now, but once we can actually start testing in the simulation environment and understanding exactly the optimal speeds between routers, independent from the car speed, all of these factors play into the league. So that's why it's so beneficial for us to do a lot of this simulation testing in digital twin technology, because for us, the speed of the car independently is somewhat irrelevant. Even if we made the car 300 or 400 miles per hour, it's really about the connection and the control between the driver and the car, which may or may not be thousands of miles apart.
The track you're working on, maybe you could describe that a little bit. I mean, is it an oval? Is it a road course? What's the size of the track? And it is a quote unquote smart track. So, what's the advantage of a smart track over a non smart track?
Yeah, no,
How does it
good
make
question.
things more
Well,
exciting?
yeah, definitely. Well, there's everybody knows what a normal racetrack looks like, and for us, the reason why we need a smart track is because the track can communicate with the vehicle, and that's very important for us and the sport. Um, there's a lot of data that we get to learn from that, and also preventative measures from damaging vehicles, where certain steps can be taken, and we can predict the probability of certain damage and make certain steps, that can reduce it. Not eliminate it. I don't want to say zero, completely eliminate it, but drastically reduce it compared to not having it at all. So that's what that is. As of right now, we've been testing on an open fields where beginners can just get accustomed to it and get a sense of what it's like to operate it, and not having any obstacles in the way. And we try to kind of hold their hand and build up with them, until they get really comfortable and really skilled at it. And then for the more advanced ones, we take them to the track, and we really get them, they get to understand what that feels like. And so when it comes down to the track, sorry, you got me excited. When I get excited, I just talk. Please cut me off if I'm going I'm going too long. Um, but luckily for us, we have got to test on pre-existing velodromes, and that's been very helpful.
So
Helpful
like a
for
little
us.
like a bicycle track, because those are really
Yeah,
banked on the oval part, I
yeah,
guess you could say, on the turn.
yeah. It's almost practice that we like to call it, and helps us learn from the next stage, which is more of a um, vertical wall. But right now, we've been testing on velodromes. They're very convenient for the vehicles because there's nobody inside the vehicles. The size doesn't have to be the same size scale as if a human driver is inside one. The only thing that's on board is live stream cameras. So because we want to keep things efficient, because we're working with, you know, the Italian designers and things of that, we really want to be smart about space and speed and weight. And we realized there was a lot of wasted space if we were to match the same size, let's say, as a Formula One. So we went with a more conducive vehicle that allowed us to test on a velodrome and then allows us to take it to more customized tracks later down the year. So that's kind of the process that we've been going through right now.
And what's the size of the car relative to a Formula One
Yeah,
car, say, or a NASCAR? What's the size of the car?
so it's 79 inches in length and 44.5 inches in width. So you can get it's roughly about a one and a half scale model sports car, with only live stream cameras on board and a pretty cool distinctive blue light, brake light at the back.
But
Right.
if you're racing, I would think latency would be very, very important. You want it to be as close to zero as you can get.
Absolutely, absolutely.
How do you do
So
that?
yeah, working with some really bright people. That's what we start there. And our guys come from MIT. They work with NASA. They're really experts in the whole spatial environments. And so for us, we're tackling that problem head on, and working on special codecs, working with some other experts in this space. Compression is a huge thing. And like I said, we are in R&D phase, and Wi-Fi is increasing every year. Speeds are increasing every year, and it's never going to go backwards, right? So we went from 4G to 5G. It's going to go to 6G. It's never going to go back, right? So you're able to build certain, functionality with that trend in mind. Obviously, you get really reduced latency when you're using a PC headset compared to, let's say, a satellite in the middle of a rural area. However, the speeds right now is like phenomenal, and what Starlink is doing, and just the ability to drive an Avicar off a satellite is just kind of it's pretty cool.
One of the things I still remember from engineering school is when you're going 60 miles an hour, it's 88 feet per second,
Mm-hmm,
right?
mm-hmm.
So
Yes.
let's call it 150 miles per hour, just to make calculations a little bit easy. But
Yes.
so
Yes.
you're roughly going to be 150 feet per second or something like that. It's up
Yes.
there. It's getting up
Yes.
there, right?
Yes.
So if we
Getting up
say a
there.
tenth of a second, that's 15 feet.
Yeah.
A lot can
Yeah.
happen in
can
15
happen.
feet.
A lot can happen. Yes.
Yeah. So
Yes. Yes.
if your latency is just a tenth of a second, right, or even a hundredth of a
Exactly.
second, which would be a foot and a half,
Exactly.
how? So I can see, like you say, you're controlling the car, and you say, hey, I want to pass this car, or I want to get around this car, or I want to move to the inside or the outside of the track. Tenth of a second or hundredth might be okay, but now you're doing that pass, and you could be inches away from another car that's also doing 100 miles per hour or whatever it is. How do you perceive that you're going to be able to handle those types of conditions where you need split second decisions and and evasive maneuvers, whatever you want to call it. Can the latency handle that, or do you have a system that will help, shall we say, help this remote driver make sure they can get through that evasive maneuver easily?
Yes, to your point, exactly. So we've called we call it Guardian Angel AI, and what it does is it helps assist some of these circumstances which you've just mentioned. There are certain frames that there will be gaps and certain signals that may not reach because of the speed of the car, just sheer speed. So for this, we're working with AI to help fill in some of those gaps and to give us a slight, much more helpful, predictable path for the vehicles, so that when the signals come back, the driver is back in like nothing ever changed, nothing ever happened. And we are right now in that process of testing how much is too much and how much we should scale it back. And based off the skill level of the driver, that's when we can kind of scale it back a bit, kind of like training wheels. And for the more beginner style drivers or feeling it out for the first time, we use a certain amount of AI until we scale it back. So there's a lot of and also there's operations being handled on the vehicles themselves that's independent from the signal with the servers. So there's a few things happening in kind of in concert with one another to make the experience enjoyable and fun to watch.
Well, you use the word feel, and you want to feel that it's real. And one of the things when you're driving a race car is the feel. Like as you're going through the turn, you're feeling those G-forces, and are the tires about to break loose or not? That's how you determine how much more you might want to turn the wheel. Is there a plan to have some sort of tactile feedback, some sort of a true physical push on you as centrifugal force, as gravity, whatever is working on the car? Mm-hmm. How are you going to do that?
Yeah. So for us, the best way where we feel we can communicate that feeling at that distance is haptic suits, and to really give that type of
suit.
Yeah.
Well, I like that.
Yeah.
So it's going to push on you somehow?
Yeah, a little bit of compression I think is really cool when you're pushing it up a notch. And then if you get, if you hit a wall or you hit a car, obviously you feel that. And then obviously if you use it in conjunction with a headset, that whole experience feels like you're in the racetrack itself.
So is that like a virtual headset and a suit that somehow pushes on you? Is that what you're describing?
Yeah. But there's many ways you can experience Avicar. It doesn't have to be just that, but there are ways where, whether it's steering wheel that's locked in position and it's stationary. Right now we're talking to so many different drivers that have their own preferences on how they want to really experience the car. And the haptic suit and the immersive headset is something that's kind of been at the top of the list. But there's also been drivers who just want to play it off their Xbox controller, or they just want to use the joysticks. That's with the Oculus or the Vive or the PSVR 2. So
we've talked about a lot of different things. So you've got this electric car. It's got sensors on it. You got a smart track. You've got latency, remote controlling, tactile feedback, tactile suits. It's first time it's ever been done. And you mentioned it earlier. You're working with Siemens and trying to take digital twin technology to help you engineer this. So in this application, maybe explain what exactly is the digital twin and how is it going to help you figure out what the final configuration, how's it going to help you design this? Because it's more than a car. It's a track. It's remote systems. How does a digital twin come in to help you make this a reality sooner rather than later?
So digital twin is remarkable technology, and it really helps us go many steps into the future in a quicker time frame. So that's very beneficial for us, right? A lot of the theories and assumptions that we can predict with the physics and our engineers, we get to really test them in a simulated environment, and that does a lot for us. That helps us reduce costs without having to try something, test it, crash it, something breaks, what happened, and trying to kind of reverse engineer things. When we get to put them in a digital twin environment and we can learn from that, that just helps catapult the manufacturing process just so much quicker and more streamlined. So, as we said, this isn't, we're making thousands of cars for this league right now. This is 11 high performance vehicles that we need the best quality and the best engineering for. So the digital twin really helps us push it and stress test a lot of these theories first before making it manufacturing and putting it on the track.
You come from the music and movie business. You founded a company called Chariot Pictures. And the things we're talking about now is you're going to have these characters in your racing series. Can you tell us a little bit about what you do? You're still at Chariot Productions. Or Chariot Pictures? What do you actually? What are some of the movies you've made? Music videos. What are the ones you're the most proud of? And how does what you've learned there helping you in what you're doing now?
Good question. So one of the videos I think we're proud of, when we've done a few, we've worked with almost everyone we wanted to work with, so that's always a good sign. But one of the videos we're proud of is the video we did with Drake and Meek Mill. Pretty big music artists in the hip hop entertainment space, and we got nominated for that video, and it was a great video, awesome production. Shot it in LA. But, I think what music videos, and we've done a ton of videos, and like I said, billions of views globally, over a decade, so it's kind of our wheelhouse. But what's interesting for us, because we're dealing with cameras, is a few things. We specialize in short form content, which is more kind of the 250, 5-minute, 20 minutes, 30 minutes short, short video, short film, intro. We've almost fine-tuned and understood exactly, really good ways to hold attention and what's considered cool, what's considered boring. We have we've learned a lot, I could say, over our years.
Well, no, go ahead.
Sorry, not to cut you off. I was trying to. So I think it works in the sense of motorsports, and I think it works in the sense of sports programming in general, because we're not looking to do the 2-hour long format races. We're not looking to do these, and I still love them. I still watch the 2-3 hour sports events, but shorter format packaged content, things that drive you into, here's the competition, here's these personalities, these guys are going head to head, this is live, and the outcome and the result could be more instantaneous. I think it speaks a little bit to our to the demographic today than the others. So
okay, so you line up these drivers. Some could be celebrities, some could be former drivers, some could be just your average person that's interested in this. And you're going to be using this digital twin as a foundation for this training system. And there's different levels, like you talk about hand-eye coordination test, simulation game, getting the actual license, and ultimately getting to the big race. Explain the steps on that so that if there's people out there listening, they're saying, wow, I think I might want to do this. What are the steps they'd have to go to ultimately become one of the 11, shall we say?
Awesome. So it first starts with the Angel Key. And the Angel Key is something that we are distributing on a very limited, exclusive basis. So we will be almost releasing them like sneakers. Like, these are very high-prized, valuable items. They can't be duplicated. It's also authenticated on the blockchain. But physical keys that activate and turn on the car thousands of miles away. So these are special keys, and no key is on earth can do this. So if you're lucky enough to get a key, and again, we're going to be doing key drops. You sign up, go to avicar.io, you sign up, you be a part of the newsletters, you get a part of the journey, and you will find out when we actually do key drops and key launches in different parts of the world this summer.
And a key drop, by that you mean that's going to be an opportunity to become one of the people that can try out. It's sort of like getting the tryout for American Idol. Oh, well, you sign up and you're going to, okay, we're going to let you come and audition in front of the judges, that kind of thing.
Exactly. Yeah. So we're not giving that chance to everybody. It's not like every Tom, Dick, and Harry can drive these cars. These are very specialized cars, as we just discussed. So we're only looking to keep it very privatized, very exclusive, and that's why we really believe in this private league approach to this. So if you get a key, you have the ability and opportunity to test drive, test the technology, drive the car, and in hopes of getting scouted. That's how we're looking at this right now.
Who's doing the scouting?
It's a combination of our internal team and the team franchise owners.
And that's really, we've been mentioning Drive to Survive several times here for Formula One, but it's that content that's made that sport even more popular. So the actual race itself, when do you think the first race is going to be? Is it around the corner? When's it going to happen? What do we have to look forward to, and when's it going to be?
Cool. So the season starts at the end of this year, starts in December, and goes into the first half of 2024.
Okay.
So that's when you will start to see the elimination process. You will start to see more brackets and that's when you will see the true competitive spirit of this technology.
Right. So starting early next year sometime, or in 24, we start to see this whole collection of people that want to be drivers, the elimination, boom, 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 till finally sometime next year, I would imagine, you're going to have the race. They sound like the races are going to be short. They're not going to be like 2-hour events. It'll be like a series of short events that eliminates it from whatever it is down to the 11. And then you put all 11 cars on the track, I guess. Is there qualifying and all that kind of thing, just like there is in other racing?
Yes. There are certain things that we're not trying to redefine the wheel here. We're not trying to reinvent the wheel. So there are certain things and certain fundamentals that are proven successful that we're borrowing a little bit from. So yes, a lot of things are straightforward, very fundamental. The technology isn't, the experience isn't. And the more kind of decentralized sports league, if you will, that I think is something that deserves to be in, and also a diversity approach. There's and I'm very happy about what F1 is doing in that regard, and they've been making improvements in NASCAR, but there's certainly a lot to be done. And I think for us, we can kind of start very organically in that sense, where certain overlooked communities and women can participate in not just the sport, but the sports ownership side of things. And I think that's really important as well.
Well, you know, in if you want to be a Formula One driver, you have to start when you're very, very young. It's a big investment in time. It's a big investment in money. This might be an opportunity. Well, you're not actually going to be driving a Formula One car, but you're going to, like you said, be feeling what it's like in some ways. And maybe it doesn't really take that lifelong commitment. So let's look a little bit into the future, right? You're going to have your race in next year. Where do you think Avicar is going to be 5-10 years from now? I'm waking up. It's race day. What's that 6 month, 9 month process look like? In 5 years, 5-10 years from now.
Yeah, no, that's a great question. And for us, we truly want to be, next to an F1, next to a NASCAR, next to a drone racing league, that's on NBC. We think we can hang with the best of them. And we think we can create this new professional sports league from the house, which has not been done before, but taken seriously because it's live, it's real, and sports competition is just a slightly different than esports in that sense. And I think for us, being in the real world, but still having that digital component, it's a hybrid. So there's no way you can kind of compartmentalize this, what we're building here with Avicar and this A0 league, which we call it. But we see it at a very high level. We see where the racetracks can do things where, we can really push the car to do, some exceptional things. Some really, really daredevil type of limits. We think we can grow this to, Avicar. We look at this A0 thing like how Star Wars IP, right? Like it has a universe of itself, but the only difference with A0 is that it's actually built on real technology that truly exists.
Cardi, thank you so much. Good luck with Avicar. Good luck with finding some great drivers. And thank you so much for joining us on the Future Car Podcast.
Thank you. Much appreciated. Appreciate you guys. Thank you.